Welcome everybody to this webinar about the IDTEAM project. I will shortly introduce myself. I am Petra and Hove, working for the Royal Netherlands Aerospace Center, and I am a training expert. I have a background in educational science and technology, and focusing on all different kind of research topics about training in the aviation sector. So first, a short introduction of the IDTEAM project. It stands for Integrated Digital Training Environment for Aircraft Maintenance. And to show you that, we will share with you a short video.
We have been talking about flexible and adaptive training for years. But how do you actually organize it? We are investigating how we can best set up a personalized digital learning environment in the IDTEAM project. What does this look like for a maintenance student? How can we build on existing knowledge and systems? We are working on a future training scenario, together with the Royal Netherlands Air Force Military School, that will be executed in a digital or real environment anytime, anywhere. Objective measurements from the training are combined with the observation of the instructor and the input from the student. This is presented in a personal dashboard. In this way, they can find together the appropriate learning path. To make this possible, we are designing a future-proof learning ecosystem and testing it with technical demonstrators. Is your training organization ready for the future?
So what was the goal of this project? It was a 3-year project. Well, we focused on developing a demonstrator or demonstrators to show the added value of an integrated digital learning environment, and especially specific for maintenance students. So what is a integrated digital learning environment? I think for most of you, you will know it, but a short summary. So what is a learning ecosystem? A learning ecosystem always starts with, in the middle, the student who is learning. And a student learns, or people, human, we are learning through activities and experiences. And in a learning ecosystem, we want to collect those experiences and activities. And ADL came up with a standard, API statements. And we try to log these activities in the learning record store. When you have the database with a learning record store, you can analyze your data with learning analytics and present it in a learning analytics dashboard. Then you can use this data in your training environment to personalize your apps and tools in your training. And the learning experience platform is the central way to combine all the information the students need to get a personal learning experience. In the IDTEAM project, we focused on this part of the learning ecosystem. We let out the data analytics and the learning analytics part because other projects were focusing on that part. So how does this look like from a technical perspective? I think many of you are familiar with the ADL total learning architecture. And this is a short summary and more simplified way to present it. There are a couple of things in the architecture that needed to build a learning ecosystem. First of all, you have systems to gather and structure your learning data. For example, the learning record stores. Then you can analyze your data, build a learning profile. This information you can use to get recommendations for your learning activities. So this is a very short summary, but in a simple way, this is your learning ecosystem architecture. So to test this out, we first started to look with instructors and with students and with all different people. Okay, what does this look like in the future? So in a couple of years, like for example, 5 to 10 years, what would a day look like for maintenance students? So we worked it out in a storyline. And we picked up 3 things in the storyline to work out and to test. So the first thing we did is we built a pre-flight simulation game. And the goal of this game was to collect objective data from the student, where we can test different things. For example, with knowledge questions, but also with procedural steps. We wanted to collect the data and also adapt the training. So there were different kind of scenarios, more lower complexity, but also very high complex levels. And during the game, the student got different kinds of experiences based on his performance. On the other side, you have not only objective data, but you have also subjective data. And therefore, we built an observation application. And this observation application can an instructor use in a real aircraft environment to collect the data about how the student is performing. So it's only observing with performance indicators. And in this way, we can collect more in a data way the subjective data. The last thing we focused on was to build a recommendation system. And a recommendation system can be part of a learning experience platform where you recommend your learning activities. So therefore, these technical guys build a recommender algorithm. So now I will give the word to Dirk Thijssen, my colleague, and he will tell you more about the observation application and other things he did that.
Thank you, Petra. Before I start presenting the concept of our observation app, when we thought about this, we felt our urge to collect subjective data, as Petra explained, and especially from the assessors and the instructors. Often when instructors assess a student, it is written down on a little piece of paper, or it is told to the student at the coffee table, but it is hard to collect that data. So we thought we need to digitalize that process to collect it for our learning ecosystem. And therefore, we came up with the ORCA process. And that is what you see in front of you. ORCA stands for Observe, Record, Classify, and Assess. Those are the 4 steps we use to structure the assessment process. And below this process, you can see some building blocks. So as input of the assessment, we need a competency framework and a qualification profile. So what does the student need to know? What for skills he needs to possess? And besides that, on a more technical perspective, you can really build it in the training infrastructure. So you can use the information of the students, so for something like PeopleSoft, where all information about somebody is collected. You can build it in your training design. You need to know all the learning tasks, so you can load it in the app very easily. And also the planning and scheduling of the training is important to connect with that observation app. In this project, we built a demonstrator. So the infrastructure is not yet in place in our app. We just focused on the training concept, but the technical perspective is really something you need to keep in mind. So then the ORCA process. The ORCA process is separated in 2 parts. So you first have observe and record. Then you have a little pause in time, so it's separated in time, and then you have classify and assess. We did that for a certain reason, because we believe the instructor first needs to observe and record data and insights of the student on how he or she performs as objectively as possible. So we don't want an immediate value of how does he or she performed. We want just objective data, as much objective as possible. So we collect that during the execution of the learning tasks, and later we want to classify that data and assess it. So then we say what he or she did was good or should be better, or to give tips and improvements. So it's really 2 steps in this process. When we look at observe, we want to do that mostly on a telephone or a tablet, because that is flexible. And if you are in a hangar, for example, you don't want to take around your laptop or your PC. So you want to keep it small and flexible. What you want to do in the observe phase is observe with the structure of competencies and performance indicators. So that is where the qualification profile comes in. So you want to score those performance indicators eventually. And besides that, you have a timeline. So when you see remarkable events, either positive or negative, you want to observe that. And then for the record, you really are going to record the data. So you have your performance indicators and you are going to score those. So features you are having are, for example, to place a comment. So when you see something or you want to remind yourself for later about something, you can use comments. You have a scoring system to score those PIs, those performance indicators. You can use different variants. You can record the events. So when you see something remarkable, either positive or negative, you can record that. And all the events you can match with a competency. So if you see something remarkable and you think it has to do with a certain competency, you can match that. So then we go to classify, and this is mostly automatically. You want the PI scores to result in some advisory scores for the competencies. So you have all the data collected about the PIs, and those PIs build up the competency. So when you take, for example, the mean of all those PI scores, you can make an advisory score for the competencies. And this automatic classification process results in a provisional grade sheet. And on the grade sheet, you can find the PI scores, the advisory competency score. You can see the comments you placed and the timeline with the events. And this provisional grade sheet you want to take into the assess phase. And the assess phase, you want to use a tablet or a PC, because it's a lot of data and you want to see that clearly. So if you have your little telephone screen, it's hard to view the data. That provisional grade sheet you want to take into a learning conversation. And before you start a learning conversation, you can also fill in complexity factors. So under which circumstances was this task performed, which says something about how you expected the student to perform. And you could be filling in the ATA parts, so that are the different parts of an aircraft on which you worked. And the learning conversation you want to use for root cause analysis. And that has something to do with the separation in time, because if you only observe, it's hard to know why somebody did something like he did it. So you want to ask him, why did you do that? To better understand his actions. So therefore, we need a learning conversation to really assess him, because maybe it was very logic to do something for him, or maybe you thought he did it because of reason A, but if you ask him, reason B was much more reasonable. So you want to really conversate about his performance and therefore explain why he did something. So you have also the chance to update the grade sheet. Therefore, it was a provisional grade sheet, because the data is not always right. So you want to update that if possible. So that's the process of ORCA. You go from observe and record, and slowly but surely you build on the assessment and make it more meaningful. How does the application look like? We have here some screenshots from the application. It is in Dutch, so don't bother very much about reading what the text says, but I can explain what you see. On the left screenshot, you see 4 names: Bob, Sienke, Petra, and Puck, and it is divided in columns. So if you go one name and you go below that, you see a competency, and you see that it's split up in 4 performance indicators. And for every name, there is a box in where you can fill in the score. So this is really about the record phase. You observe the student and you read the performance indicators and you give the score. So here you can observe 4 students at once. And below the performance indicators, you see other competencies. So you can make the competencies hide or you can show. So therefore, it is easier for the assessor to assess multiple competencies at once. The screenshot on the right shows the timeline. So the remarkable events you want to record, that is what you're doing here. So you can say something, you can give the title, you can explain what happened, and you can connect it with the competencies. So that are the labels with the colors you can see. And also you can label it to certain persons. Maybe only 2 of the 4 students you were observing were connected with this event. So this is about the record phase. And here you record all the data, and then you want to take it with you for a provisional grade sheet and go to the assess phase. And that is what you see here. So this is much more suited for a tablet or a PC. So here you see all the competencies split out. You can see all the performance indicators and the scores you have given them. On the top right, you can see student. So you can select the student you had observed. So if you would click on there, you see the 4 students. And we did that because in the conversation, that is one-on-one, so the student and the assessor, and you don't want to bother with data of somebody else. It wouldn't be ethically suchly sufficient, and you want to view only the data with the student you are talking with. Yeah, so this is a screenshot about the assess phase. So we really have 2 phases, and also the application shows that. So that is the observation application in short. Here can you see as well the timeline. So that comes back in the observation application. And that's it about the observation application. Another part we researched in IDTEAM is the progressive scoring system and a recommender. And what is behind this is the urge to have all these data from all different training media, simulators, but also the task you perform on a real aircraft, for example, or simply you read a book that was mandatory. So you have all these sources of data, and how are you going to connect that to build one picture of a student? That was the problem we encountered, and we wrote a paper about that. And all that data, you want to build a picture, and then you want to recommend the best next learning activity to a learner. So we wrote a paper about that, and also what do we need to do so? To recommend the right learning activities, what do we need? It's pretty mathematical, the paper. So if you want to read the exact formulas, then please search up the IETSEC paper or contact us. Yeah, so in this presentation, we really going to talk about the concept, not really the formulas. This picture we saw it earlier, and we wanted to point out where does this recommender framework and this progressive scoring system connects to the architecture. So when we have it about the progressive scoring system, It is aimed to quantify learners' proficiency and the progression through the training. So that is really aimed about the competency framework you need. So that is highlighted, and the learner profile. If we have that in place, we are able to recommend new learning activities to the learner. So that is more in the lower part of the architecture. Then you have about recommendations and to predict how we would score. You have an experience index, which says something about all the experience that are available. So it's and what would be suiting for the learner. And eventually you want to present those insights in a learning experience platform. So that is to recommend our algorithm. Before we started developing these systems, we thought about educational principles. So how should the technology behave? And it should behave in a way that suits human learning. And we came up with 3 principles. The first one is competency development. So we really want to take in the structure of competencies. And the second principle is the flow of learning. So there is a flow of learning which is shown on the right, where you can see in what zone do you want to learn in. So on the y-axis, you can see that challenges is going from low to high, and on the x-axis, you can see skills. So whenever the student progresses, so he becomes better at his job, for example, you need to challenge him more to learn him new things. So therefore, the flow channel in which you want to learn is slowly but surely going up. But if you over-challenge the learner, you can talk about overload, which causes, for example, anxiety or demotivation. But if you challenge the student not hard enough, it's too easy, you get underload, which can result in boredom. So that is one principle we took into account. The third principle is the zone of proximal development. And that is the zone in which a learner can learn. It's something new, but it's just that bit too hard to do it independently. So he needs the help of instructors or training media. And if you connect that to the flow of learning, it would be the upper brown part. That is where the zone of proximal development is located. So we used these 3 principles to build our system. First of all, the progressive scoring system, which we use to quantify somebody's proficiency and progression. It consists of 3 parts. The first is create a mesh. So a mesh of data. What should a learning activity put out to create a learner profile? So we have all these training media, and what should they collectively put out so we can make that mesh and create that learner profile. We thought about that. The second part is an ELO rating system, which is a system that already existed, and we use that as inspiration to quantify the proficiency and progression. And the third part is competency framework. So that is our structure of the learner profile. Here you can see an example of the ELO rating system. And the first line, we gave the proficiency of the learner a continuous number. So you can see this as a score. So for example, when I perform a task and I look at a certain competency, I give myself 900 points. And how higher the points, how higher the proficiency. You can do the same for the learning task per competency, but you are not talking about proficiency, you are talking about difficulty of the learning task. So for example, the difficulty of the learning task is 800. If you have these 2 digits, these two numbers, you can calculate an expected win rate or win chance. So in this case, my proficiency is higher than the difficulty of the learning task. So it is expected that I have a higher chance to win or to perform well. So in this case, if you make the math, you have a 64% chance to win. So this is all calculated before somebody is performing the task. It's a prediction. When somebody has performed the task, you can get a result. This can be a score from 1 to 10. This can be an A, B, C, D, E score. This can be something else. But you need to normalize that score to a score between 0 and 1. So in this case, it would be 0.75. If we use that result and we put that in our formula, and we also know the expected win chance because we knew the proficiency level and the difficulty level, we can calculate a new proficiency level, which is 912. Because I performed well, I performed 0.75. I was expected to win, so therefore my proficiency level goes up. And if you would do this on a bigger scale than just this one example, you can see the competency development over time, which is shown in the plot on the right. You can see 3 competencies with 6 activities performed over time. And you can see that the competency grows and grows whenever there is an activity on that competency. Not every activity is relevant for every competency. So therefore, sometimes there's no growth for a competency. And you can even see sometimes a drop in competency level or in proficiency level. That's probably because he performed worse than expected. So therefore, there is a downgrade. So this is, in short, the principle of ELO rating system and how we turn that into a progressive scoring system to create that mesh of data. So here you see a table with the concept, really, the dynamics. Because we have a proficiency level and we have a competence and a difficulty level, we can say how relative the difficulty is to the learner's proficiency. So if we make it really simple, we can say it's equally proficient or difficult as the learner, or it is hard. And on the left, you can see the result. So either a win, tie, or lose. In training, we don't have win, ties, or lose. We have, for example, a 10 or a 0 or A or a E and everything in between. But we can normalize that to 1 and 0 and everything that is in between. So, for example, when you win a very easy task, it's expected. So the growth would not be that big, or maybe there isn't growth at all. If you win an equal task, well done, and you rise in your proficiency score. If you win a very hard task, which is expected, you grow even more. So if you look at it from the other side, if you lose a very easy task, it is also unexpected. So therefore, you lose your proficiency points. So this is the simple dynamics of the ELO rating score. And when we go back to the 3 parts we talked earlier about, we said, what do we need to create this system? So what does a learning activity need to put out? So what we have created is a simple to have periodic and ordinal grades and convert them to a continuous score which says something about proficiency. And what we need from a learning activity as output are 3 things. We need a competency weight, which we set prior. So a competency weight says how relevant the learning task is to train that competency. And on the table on the right, you can see an example. For example, the competency safety awareness. You can see at the W that there is 0.5 for learning task A. So on a scale from 0 to 1, it is 0.5 relevant for safety awareness. The second thing we want to have from the learning activity is the difficulty level. So we say when a difficulty level is applied when the relevance or the competency weight is higher than 0.5. So in this case, it is higher, and we have a difficulty level of 600. So the whole syllabus of your training, you want to create these insights. And this is what we call the experience index. And all these things can be said about the syllabus before somebody performs a task. The third part is the score per competency. So this is something as an outcome. For example, the observation application gives us a score per competency, but you can also think about learning analytics from a simulator. So these are the three things we need to make the system work. And if you do that, you can work with the progressive scoring system. And then we have the recommender system. So when you have the progressive scoring system complete, you can make a learner profile, and you can say with one continuous number per competency, you are, for example, 800 points in that competency, and you need to grow to 1400 to graduate, for example. How do you get from 800 to 1400? Therefore, you need new learning activities and new experiences. So we built a recommender system, and the recommender system looks into the learning profile and searches for competencies that are lacking behind. It's relative to other competencies, so you want to search for those weak spots and select activities that train those competencies that you have selected. The selection can be done based on the win rate. You can make a prediction of how hard the learning task would be, because we have the difficulty level and the proficiency level. And you can say for the learner, there is a 70% win chance. And here is where the educational principles also come in. For example, the flow of learning, we say it keeps you engaged, but it's not overly challenging. So we can say it is between 60 and 80% win chance. The proximal development, we say that is challenging. You can't do that on your own. You need some help of your instructor or a training media that helps you. So we can say there's a win chance of 50 and 60% for proximal development. So that is the bound we are searching for new activities between 50% win chance and 80% win chance. That is also seen in the plot on the right. And what we have done in the recommender system is we want mostly to look in the middle of that flow, we call it, the flow between 50 and 80%. So therefore, we distributed a normal distribution. And we say we want a random target in that normal distribution. So mostly it would be in the middle, but sometimes it pushes the bounds to go extra hard or to go easy. So you go towards 50% or towards 80%. If you have that random target, you are going to search for those activities, and you want to calculate the fit to that random target. And then you want to select the activity that is close by of that random target. And maybe you want to select 3 activities, and you give that via the learning experience platform to the learner. And he or she can select which activity is the most suitable for him. And that is the next activity he is going to do. Now, why are we using that random target? Because that flow is not fixed. It can move over time. And from time to time, we want to push that flow. So when we see somebody does very well, when we challenge him hard, we can put that flow more to the left. So everything becomes a little bit harder. But on the other way, if it is more easy for him, and that works for that student, we can make the plot of the bounce go to the right. So it becomes more easier. So that is the way we can play with that flow. So that is what we take into account in the recommender system. So there's a flow, and we want to train the competencies that are lacking behind. For future development, we also want to look at the dynamics and the algorithms, because they are yet to be validated. So the next steps are use cases to do so. We also have ideas to expand the model. For example, self-efficacy. If somebody is low in self-efficacy, maybe we can give him or her an easier task to up that self-efficacy. We also want to expand the model with skill retention. And we are searching for a methodological approach to fill the experience index. So how are you going to say it is that difficult and this relevant? So that is the progressive scoring system and recommender in short.
Next up, future work.
Yes.
We'll switch to Rick Bosma, my other colleague.
Hi.
Maybe you can flip the camera a little bit more, so you can. Yeah.
Hi. My name is Rick Bosma, and I've been the tech lead on this project, IDTEAM. And of course, we had a huge success in our findings and the stuff we did. So we want to continue our work. So I'll discuss a bit of our plans for the future. Nothing is set in stone yet, but those are our ideas, and we would like to share this with you. I have to press the right button. Yeah, there we go. So basically, we look at the total learning architecture by ADL. And of course, there's way more into that than the previous shown picture. So basically for IDTEAM, we considered one learning record store, only a noisy learning record store. For our next project, we want to do several things regarding collecting and structuring all this learning data. I'm trying to continue that. Also, there's a bit of learner analytics where we see group analytics, analytics about learning activities, and so on. And of course, we have the learning inference where we use the data to actually say something about how a student performs. This combined with the competency framework, of course, makes the learner profile. And finally, we have this design paper written. We are going to present on the IDTEAM, and that's also the moment when we are going to share that paper, right? That was a question from the audience. And of course, we want to continue to make a proof of concept about our design for the recommendation system and the progressive scoring system. So I'll go into a bit more detail there. So for the structuring, what we notice is that a lot of people are trying to collect data from simulators and simulation environments. And we want to create some kind of XAPI toolkit that you can use on either like PETS tooling or on your simulator, and actually extract the data in like a low effort way in a lot of different situations. This is just a dream. We don't even know if this is technically possible, but we try to make it happen in future work. Also, a really interesting topic for us to look into is how to convert data from your noisy learning record store to your transactional learning record store and use the TLA master object model for that, how you can convert this data. So we have a Q&A question, like, do you also look into these kind of problems, and can you maybe work with us on that, or maybe even help us if you have some prior experience there. Last but not least, click. We want to see if we can translate the competency frameworks and the qualification profiles we have now in our Netherlands MOD. If we can, whether we can convert that to the shareable competency definitions, which is IEEE standard by ADL. And that's something we want to look into as well. We really would love to hear your ideas about this, your thoughts about this, and feedback as well. If you're like, hey, we already did this. This is like a match we already won. Please share your findings with us. We're really interested in that. Also, for the learner profile, in Europe, we have this really nice law about privacy, the GDPR laws. Which basically says that we can't transfer any personal data between companies or squadrons or anything. And what we really would love to do is from pre-education stages of a learner to actually use their learner profile through their entire career. So also in their schools within the MOD, but also during their careers. And to be able to transition all this data, you really need to deal with this law at some point. And you can use all kinds of technical solutions for that and all kinds of legal solutions for that. And we really want to help our MOD to deal with those laws. Another thing is for us now, learner profile, we looked at it as a kind of log of all the stuff somebody did. And those can be activities, but also informal learning experiences. Also, we store our findings about how well somebody performs and their scores, like Dirk just explained. But we also want to learn what's, from what we understand, there's more to it, and we want to know what it is. Now, last but not least, in the learning experience platform, we want to see how we can actually convey all this information and translate this data into information to present to the learner. Well, the progressive scoring system, and which we are going to present, or Dirk is going to present on the IETSEC, that's now a design paper. And we want to create a proof of concept to actually test our algorithms, improve our algorithms, but also to integrate it with the whole total learning architecture. Like we mentioned several times, we're going to present this on the IETSEC. That will be on the 1st of December, early in the morning. But yeah, we think it will be worth your while, and we would love to have you there and answer any questions. We also have an NLR booth on the IETSEC, so feel free to visit us. We'll be there, and we're happy to connect with you.
Yeah, so a lot of technical information to your side. But what did we learn from all this project and what we dive into? So first of all, what's important is to focus on to support the learner to do his job. And why is this important? For example, in the beginning of the project, we talked also with the students of the defense, and we asked them, what kind of tools are you already using? And for example, there were also mobile phones available, but the student was saying, I'm not using mobile phones. I just asked my instructor. So you could have the tools, but you need to know if your learner is using the tools. Another thing what's important, and you can give the other one, it's about the XAPI statement. I think most of you are familiar with the XAPI statement. If not, you can dive into on the ADL website. There are a lot of information about this available. And one of our questions was to find out which data is relevant to store in your XAPI statement. And XAPI statement contains of different aspects. You have, first of all, the objects. Yes. So you need to know about who is performing the task. You need to have the verb, the action, and there you need to store the task, what someone is doing. And the object, and that's what we find, it's important to store the performance indicator. And performance indicators could help to make it more standardized. So you can store a lot of information in the XAPI statement, especially from simulators. It's all what we saw in our pre-flight simulation game. For example, he opens a door, or he's walking through the hangar, or he's clicking on an object. And you get a lot of information. But what's important is to store what is the performance indicator, what does someone do. And you can categorize those things and connect it with your competency framework. What's also important is to take into account the context in the XAPI statement. This is one of the important things, especially to understand what someone is doing. And for example, you can store also the complexity factors. So what's making it more complex, the task. And of course, the results of the activity. So the next is not a tip, but is more finding we had. We were working with a lot of defense systems, and those systems are very secure. And so it's very difficult to take data out of these systems. So that was very challenging, and especially with the defense, it's difficult to use cloud-based solutions. And many systems in learning ecosystem are cloud-based. So that was really a challenge. One other thing, it's very important to have clean and big data to make more prediction models and to automate systems, but it's not always available. And especially in maintenance, we have small classes, small groups with, for example, 8 students per year. And then it's sometimes difficult to make all those algorithms. So it is important to make your course effectiveness things. And for example, the observation application with collecting the objective data, the subjective data, could help. And it could be better than maybe collecting data from a simulator. So it's important to keep the human in the loop and let the human decide about the data. For example, one of the aircraft systems, one of the main secure systems, what the instructor were doing is they take out the data and just next to the simulator, they look into the data, see the objective data, but then talk with the students about the data. For example, they see misclicks or things they don't, and go to the procedure and ask them, okay, what was happening here? And after the lesson, they will collect this data in a subjective way in their system. So the objective data is still in the secret environment, but you can use it in, for example, in your observation application. So that were the main lessons learned. We have a lot of more, but we can't tell you everything in 1 hour. Thank you for listening. We are very interested in your questions. I want to thank also the Ministry of Defense of the Netherlands that worked with us to do this project. And here are our contact details.
Thanks, Petra.
So, any questions, you can set it in the chat or something else, Q&A. And if you want, you can unmute.
I think we've got a question in the chat so far, and then we can get to raised hands. Do you see the one in the chat from Sophie?
Yeah, I can answer that question. So basically what we also did is create a 3D training environment where several levels were built. And one level would be easy and the other one would be really hard. And those would have different complexity factors. So in that case, we actually put the complexity levels in the extensions of the task itself, because some specific tasks were more complex than others. And if like an overall training would be more complex, then we would put it in the definition of the learning activity itself. In some cases, for example, real-life training exercises, we would supplement this later in the XAPI statements. And does that answer your question? You can type it in the chat if you like. I saw a question or a hand raised by Lydia and one by Alec. Lydia.
Hi, thank you. Can you hear me?
Yes.
Excellent. For the last 5.5 years, I've been a training manager for aviation maintenance at the ROC airport in Hove. And I am highly advocating competency-based training and assessment and self-paced learning. So we are completely redesigning our curriculum accordingly. However, we also work closely with the Dutch Air Force, and we talk a lot also. And the message we always get back is no matter how well you train your students, no matter how well you have all the competency frameworks and everything, without the parts modules, they are basically useless. So they have to get all their Part 66 modules, and otherwise I don't care how well they perform. That's roughly, in very black and white, the message I get. So I'm really happy to see that you managed to collaborate with them on this level. However, I wonder, how is their fixation on this and their priority on this integrated in what you just showed to us, which looks really good, by the way. My compliments.
Thank you, Lydia. Yeah, it's a really good question on this thing of regulations, I think, because it is in the regulations and they are audited by, in this case, the Dutch Military Aviation Authority. So that's why they are doing it and focusing on it. But I think, yeah, it's a side matter and you need to focus on indeed on the competencies of someone. It's more important. Yeah, I agree with you. Is that answering your question or?
Well, yeah, I'm happy you agree, and that's great. I just wonder, and to which extent do they agree? I mean, is this in any way integrated, or are these two completely separate worlds in the approach of training the students?
Good question. Maybe we can talk about it later on, further on this, Lydia, because it's very specific Dutch thing.
Dutch MOD, yeah.
I think about the regulations. Every national security institute has regulations. And you often see regulators are very conservative. So in this case, it's about the safety of aircrafts and the personnel that are operating those aircrafts. So it's logic that they are conservative, but it's also our duty as innovative organization to show the results we show here to the regulators. So they see, this is around, and so they can also slowly but surely update their regulation.
Because of time, I think it's good to answer another question.
Yeah. Yes.
I see Alec Walker. Raise your
Thanks,
hands.
guys. Yeah, great presentation. I learned a lot from it. I don't know as much about the Dutch system. We're working with the US Air Force. And a lot of the same challenges you guys talked about in your challenge number 4 about not having enough data was an impetus to actually set up an automated question generation system so that those who are creating courses can inject more questions into review sessions and have more practice questions and so on. So we're able to generate more information about how a learner is doing and then try to start tailoring the learning process to the individual's needs, as opposed to kind of a one-size-fits-all, training curriculum. So this is starting to be adopted by the Air Education Training Command. But I think that the actual, the plan for how the adaptive learning is going to work, the question generation part is pretty solid now, but the question for how the adaptive learning is going to work, I think we could learn a lot from your approach. So I guess wanted to plug that to see if we could talk later, but quick question is, do you sense in your situation as well that one of the challenges to creating the data is the bottleneck of who's going to create the questions that then allows students to react to them to understand where people's competency is.
So, do you have the sense in who's creating the data, or especially the questions? I understand it well, or?
Yeah, is the bottleneck, is the reason why it's hard to get enough data so that you have enough labeled data to do nice, figure out your adaptive learning, is the reason that that's hard because there aren't enough questions to determine who is competent in what area, because it's so hard to generate those questions.
That's definitely true, and especially in the aircraft maintenance, you have like the multiple choice questions, and they are all set out, and that's not always what Lydia also talking about. It's not also about the competencies of someone, and it's really difficult to measure that and to have good performance indicators and to observe them. And especially what we were trying was also taking data out of the objective data and to automate those things into performance indicators. But you still need people who look into that and to convert that and connect it. And that's very difficult to do. So it takes a lot of time, especially to set up a system and to collect those data and having good data, not only the data is not making any sense.
Yeah, and we also looked into like historic data, but of course the whole maintenance work field was kind of different 10 years ago than it is now. Yeah. And if we look over a span of 10 years, we're still looking at like several hundred people doing educations. So it's still not a big data set at all to do any kind of machine learning or anything. So what we basically did, as you noticed already, I guess, is that we went to like, what do we have now? How's the process done now by the instructors, by all the people surrounding the learning system? And how can we use that to our benefit and maybe automate it a bit more and put it into the whole learning ecosystem approach or TLA approach? Yeah, but yeah, it's a hard thing. What we're also doing is like, how can we create some synthesized data that will help us actually make our algorithms better and also understand the student better. And that's also really low TRL technology readiness level research we're doing. So we're not sure yet whether that actually will work.
I see we ran out of time. It's already time, but we have still one question. But everyone who needs to leave, we want to thank for your attention. And as Liz already told, about 1 week they will upload all the information, the presentation, but also a video of this webinar.
I've seen a couple people ask. Yep, I think you're about to say the same thing. Ask about a link to your paper. Do you have that? Would you like to throw that in the chat before everyone leaves?
Well, the paper will be published during the IDTEAM, which will start on the
26th of November.
Yeah. So in a month, and then the paper will also be published. But I guess we can share the link by then. Yeah. Via your channels, Liz?
Yeah, we can send it to everybody who attended this.
That would be great.
Yeah.
I saw that Mr. Ball had a question. Do we want to?
Yeah, yeah. Thanks for taking my question. So one of the things I'm involved in is looking at data that is generated from original equipment manufacturers, because they do their own analysis so that they can create their own maintenance documents and when they're involved in training. Have you engaged anyone from industry in terms of the type of data they would have that might include things like learning indicators and that sort of thing? Or is this just within the military sphere?
This project was in the military sphere. However, we teamed up with a small medium enterprise who are making a lot of virtual reality trainings, e-learning, stuff like that. And we partnered up with them to see how they would approach it, to see what kind of data we need to store. And from our department, we're also doing a lot of modeling and simulation. So we provide a lot of simulation environments for training, and we use those inputs as well. But you have to consider that that's military minded as well. So those are, for example, F-16 flight simulators and stuff like that. Does that answer your question? Or?
Yes, thank you.
Okay, great.
Okay. Any other questions left, or?
I saw a question in the chat, like what booth? Yeah, we do have an IDTEAM booth. And I don't know the exact number or the location, but you'll sure find us. Yeah.
All right. Thank you. Well, thank you for everybody for joining, and thank you for asking so many great questions. I just want to thank our presenters one more time today. Yay, good job.
Thank you.
And thank you for joining us and telling us everything about your project. If you want to stay tuned to the ADL website, a recording of this will be up online by the end of the week. And stay tuned for any future webinars that we put out on that page as well.
Thank you very much.
Thank you. And have a great afternoon, everybody, or whatever time of day.
Bye-bye. Have a great day.
Thank you. Bye-bye.
Bye.